Another undergoing work is development of unmanned surface vehicle. So we are yet to develop this particular vehicle, but however the preliminary testing has happened. And this is an ongoing project from the SERB equity funds, and we have got this particular configuration of unmanned surface vehicle, which is different than the previous case. In the previous case we have used hovercraft system, but here we have used the floating type of system. We have deployed these kind of floating type of system also onto the water surface to move along the water body. So this is ongoing work. So we have deployed this unmanned surface vehicle near to a water body. You can see a water sampling system. So this is a water sampling system to collect water samples. We can control this each walls with the help of our radio frequency signal, and it can also automatically switch on switch off based upon filling of each bottles. For example, I have got 4 bottles. Once the first bottle is filled, that corresponding bottle valve will be deactivated, and then it will be automatically going into another water sample. So for example, I want to inspect the water quality of different points of our interest. So the first bottle will correspond to the first point, and the second bottle correspond to the second point. Like that, we can plan the sequence of collection of water samples and ensued water quality monitoring with respect to the particular point of our interest. So the water sampling system is also planned in such a way that the ensued water quality monitoring and the corresponding point of our water quality of that particular location of interest to collect water samples should match. So that is the plan in terms of understanding the water sampling system. So we have got all the pumps, all the solenoid valve actuators, it is planned in such a way that we were able to control the entire systems effectively with the help of radio frequency signals and servo actuators. So that was the thought process which we have developed. It yet to publish, so I am not disclosing many intricate details onto this water sampling system. And this is the first level test we have done our unmanned surface vehicle. Now we can see a small video how this particular vehicle is deployed and how this water samples have been collected in a remote water body near to our institute. Now we will see the video. This is our team. We have launched this vehicle onto a water lake. Now the vehicle is moving on to the water body. If you want to move left and right, your rear side surface control surfaces can be activated, and it will be able to move, and it will be able to control the direction of the vehicle where exactly, and you want to position this vehicle at that particular point, you can hold that particular point of interest to collect the water sample as I explained earlier. So this is a sampling point 1, and that particular sampling point 1 you are able to collect water sample at particular water bottle number 1. Like that we have planned the sequence in this particular unmanned surface vehicle. So this is a snapshot of top view of our unmanned surface vehicle. And once this point number 1 we have collected the water sample, then we were moving into subsequent points. So similarly we are able to move in a different points of interest. That is what the beautiful nature of these kind of unmanned surface vehicle. So this unmanned surface vehicle is again, it is another kind of amphibious characteristics which will be also moving into the water body and flying onto the airborne mode. So these are all different points of interest which we are moving on to the water body at different location of our water body. As you can see, it is a very large water body where our UAV were able to, our unmanned surface vehicle will be able to move at a different sampling point. Now we are collecting the water samples at sampling point 2. So similarly you can collect, we can plan the mission, and we can collect the water samples and understand the contaminants of water at the particular water location. We can deploy these kind of unmanned surface vehicle at the desired location of water body. Any number of water locations can be done with respect to this unmanned surface vehicle. So that is the advantage of this kind of vehicle. We can locate the position of the particular GPS location of the particular water body, and we can collect water samples. So n number of locations, n number of points of our interest can be easily collected. Now you can see after collection of water sample, we have dismantled the system. Now we have redesigned the systems as per the modification. We can keep all the water samples outside also. Now this was the first prototype which we have done this particular work. So now we can see the water samples, and we were able to remove all the water samples, collected water samples Now you can see the water sample 1 which was collected, this water bottle number 1. So similarly, you can collect n number of water samples using this unmanned surface vehicle. This is an ongoing work which was funded by SERB Equity. This is a first level proof of concept which we are working for further modification and improvement on to the unmanned surface vehicle deployment in a different water body locations. To summarize, in this week we have understood the development of unmanned amphibious aerial vehicle for water quality monitoring, and initially we started and learned about the various conceptual models of amphibious unmanned aerial vehicle. We have evolved into 12 different models in which we have selected one of the conceptual models, and then we have considered that particular conceptual model for further analysis, and that particular conceptual model we have evaluated with respect to the strength characteristics. For example, we have understood the finite element analysis of the multi-rotor frames, hull structure, skirt structure, what kind of material can be selected. We have compared all the materials and we have evaluated the performance characteristics with respect to the strength and also the strength of the particular structures, including the hovercraft structure and also the multi-rotor frame. So that was happened in the first phase of our explanation, finite element analysis, and the second phase was focused on computational fluid dynamic analysis, wherein we have focused on various flight mode conditions. For example, in the hovering condition and in the forward flight conditions, how this particular flow analysis happened in terms of a complete integrated system of hovercraft and multi-rotor system. So initial understanding on the flow analysis and the structural analysis was explained to understand the complete design aspect of the amphibious unmanned aerial vehicle. So after finalizing the first phase of theoretical aspect, then we move on to the selection of components for the individual subsystem components. So we have selected all the subsystem components, and based upon the requirement of our payload conditions and other mission requirements to withstand the payload conditions and external wind factors and other factors, we have considered all these aspects and we have selected the skirt materials and the hull materials, and after selection we have just stitched all the skirt and the integrated the hull structure. We have made the hovercraft system, and we have also compared the theoretical aspects and the practical aspect, the performance characteristics with respect to the back pressure and all the pressure requirements to inflate the skirt and the all the aspect of hovercraft development. We have fabrication aspect, we have done the initial understanding, and then move on to the multi-rotor frame. We have understood the fabrication of multi-rotor frame and integration of hovercraft and multi-rotor frame, and then the subsystem integration, all the electronic integrations, all those aspects we have dealt. And after understanding of all the integration of subsystem, we have deployed into the real-time subsystem deployment. And that real-time deployment, we have integrated various water quality sensors. Initially, we understood about various water quality sensors and calibration and testing into the laboratory level, and then in-suit measurement. Further, we have integrated all these water samplers and water quality sensors into the amphibious UAV, and we have deployed this UAV, some of the water bodies, lakes of different regions we have explored, and we have investigated the lake parameters also was explained clearly. And finally, we have integrated this IoT platform to transfer the data from the amphibious UAV to the ground control station. So in a nutshell, we have understood how these kind of unmanned amphibious aerial vehicle can be effectively deployed for water quality assessment, inspection and monitoring in remote water body, especially in remote water body. So that kind of understanding will help in future to develop these kind of vehicle for your own requirements of water quality assessment. At this juncture, I would like to thank Geeta CAI DST for the funding support under the Indo-Korea collaboration project, and SERB Equity, which is ongoing, for the support provided by them for development of unmanned surface vehicle. And earlier I executed this particular project, Center for Autonomous System Research, Vehilce Rangarajan, Dr. Sakunthala R&D Institute of Science and Technology, Avadi, Chennai. UCAL System Limited was the industry partner under this particular Indo-Korea collaboration project, and Convergence Research Center for Wellness at Republic of Korea, DGIST, are the Korean partners for the institute site, and Rovitech is again the industry partner from the Korean side, Sun Moon University, who has supported for this particular Indo-Korea project. At this juncture, I would like to thank all these partners for the support rendered during the execution of this particular project. Thank you.